My name is Vashist Baburao Mhalsekar, Assistant Professor, Department of Medical Imaging Technology, Yenepoya School of Allied Health Science, Yenepoya deemed to be University. Today I am going to discuss on the topic of basic principles of MRI. So before going to deep discussions in the topic, we will see about a few specific learning objectives. So at the end of the session, the audience will be able to describe the basic principle of MRI, to list out the types of motion in an atom, explain the precession and results of resonance, define free induction decay, and to explain about the T1 recovery, T2 decay and the pulse timing parameters. So coming to the atomic structure, going to the deep about this topic. So the atom consists of central nucleus and the orbiting electrons. So as we can see in the pictures, electrons are present in the atom on their orbit, then nucleus is present, and a nucleus is having protons and neutrons. So atomic number is the sum of the protons in the nucleus, and the mass number is the sum of the protons and the neutrons in the nucleus. So the electrons are the particles that spins around the nucleus. Coming to the next, it is the main part, that is a motion in an particular atoms which is present in our body. So the atom consisting of, as I told you, the atoms consisting of the electrons, protons and neutrons, and the nucleus also is present. So first motion is the electrons spinning on their own axis, electrons which are present on the axis which will be spinning or the rotating around its own axis. So second motion is the electrons orbiting the nucleus. So whichever electrons are there present on the orbital axis, which will be orbiting around the nucleus. So the third one is the nucleus itself spinning on its own axis, which nucleus present in the center of the atom, which will be spinning on its own axis. So basically the principle of the MRI rely on the spinning motion of a specific nuclei present in an biological tissues. So coming to the next one, that is hydrogen nucleus. So everyone knows about our human body is made up of maximum amount of the fluids designates for the water level. So water in chemical formula known as the H2O. So number of hydrogen atoms will be present in our more in the body. That's why we are using as hydrogen we are focusing in the MRI system on the hydrogen atom, because it is very abundant in our body. So it gives a relatively large magnetic moment. So next one is the hydrogen nucleus act as the magnet. So in the MRI system, or else in the basic principle or the physics of the MRI, basically magnetism and charge and the motion, these three components are important. If any of these three are present, then the third one will be automatically induced. So the charge, if it is present and motion will be present, then the magnetism will be automatically produced. So that is why the atom which is already moving around itself, surrounding itself, or within itself only moving. So what will happen? Magnetism will be automatically produced surrounding itself. So now coming to the main part, that is the magnetic vector. The magnetic vector designates the direction and the size of the particular magnetism. So next one is coming towards the alignment. We all knows about the hydrogen atoms, or the atoms are randomly oriented in our body. So in the first picture we can see that hydrogen atoms are the randomly orientated. They will be placed here and there everywhere in our body. Okay. Now they have to be aligned. So how it will be getting aligned? So we are giving the external static magnetic force so to align all the hydrogen atoms in a particular one directions. Okay. So in the third picture towards downwards, we can see the sum of the hydrogen nuclei aligned parallel, and some of the hydrogen nuclei will be aligned anti-parallel towards the magnetic field. So in the next slide we can see the low energy nuclei in the magnetic moment are parallel to the external magnetic field, because whatever external magnetic field we are applying, so the low energy nuclei are there, which is they are parallel to the external magnetic field, and the high magnetic nuclei, some of the high magnetic nuclei will be present in our body. So, it will showing as the antiparallel to the magnetic field, as termed as the spin down nuclei. So, in the picture we can see the parallel low energy nuclei are more amount, and the high energy nuclei which is facing downwards are in less in amount or less in number. Next one, coming towards the precession. So, each hydrogen nucleus is spinning on its axis, that we know, because atoms which are having already charge and motions will be already spinning due to the electrons are spinning due to the all three motions of the hydrogen nuclei. So, the influence of the external magnetic field or the static magnetic field produces an additional spin around the hydrogen nucleus. So, we can see in the picture that already spinning of the hydrogen nucleus is happening over there. So, the additional spin that we are giving, that additional spin is known as precession, and it causes the movement to follow a particular path. Certain path is there, we can see the above the circular path will be there, that is known as the precessional path, and the path with the particular same speed or the particular speed which will be a hydrogen nucleus will be rotate is known as the precessional frequency. Then most important thing is the Larmor equation. So, the Larmor equation states that the omega naught is equal to B naught into the gamma. So, where the omega naught is the precessional frequency and B naught is the magnetic field strength of the magnet, and the gamma is the gyromagnetic ratio. So, what is the now gyromagnetic ratio here? Because already we have saw what is the precessional frequency, then static magnetic field, that is B naught we saw already, that is external magnetic force we are giving. Then coming towards the gyromagnetic ratio, the gyromagnetic ratio is the relationship between the angular momentum and the magnetic moment of each MR active nuclei. I repeat, the angular momentum and the magnetic moment of each particular MR active nuclei. So, already hydrogen atom is having fixed number, that is 42.57 megahertz per Tesla, and unit of, I repeat, the unit of megahertz gyromagnetic ratio is megahertz per Tesla. So, hydrogen atom has having same amount of fixed amount of 42.57 megahertz per Tesla, that is the gyromagnetic ratio. Okay. So, if the Tesla machine changes, varies from the 1 Tesla to 7 Tesla, that means the gyromagnetic ratio of the hydrogen atom will be shifted from the 42.57 into 7. If the Tesla machine which is present in our department or as which is present in many clinical diagnostic centers, if the machine is about 0.5 Tesla, then the gyromagnetic ratio of the hydrogen atom in that Tesla machine will be 0.5 into 42.57. Okay. So, coming towards the next, that is the resonance. So, resonance is the phenomenon that occurs when an object is exposed to an oscillating perturbation that has a frequency close to its own natural frequency of the oscillation. So, already hydrogen atom has been rotating. So, if you are giving more extra energy which is close to its own natural frequency, that time resonance will be occurs. Okay. So, the energy at the precessional frequency of hydrogen atom at field strength in a clinical MRI corresponds to a RF frequency or RF band of electromagnetic spectrum. So, for the resonance of hydrogen occurs, an RF pulse of energy at exactly the Larmor frequency of hydrogen must be applied. So, the application of RF pulse that causes the resonance to occur are known as an excitation. Coming towards the results of the resonance, so whatever till now what we have seen, the precessional and the resonance. So, precessional means we are giving the energy which is close relative energy to the moving structure of the hydrogen atom, and the resonance is the occurrence which is the applied energy which will be having the close to its hydrogen atom which is spinning around its own axis. So, coming to the what will happen after the resonance, what will happen after the precessional frequency, what will happen after the static magnetic force is applied to the particular atom. So, the first what will happen is the net magnetization vector, which is the first one, will longitudinal direction will be moved out of alignment, that is away from the B naught, when the sum of the low energy nuclei are giving enough energy via resonance to join the high energy population. The angle to which the net magnetization vector moves out of alignment is known as the flip angle. So, whichever angle, whichever energy, how much energy we are putting for the hydrogen atom, so whichever energy the net magnetization is flips towards the whichever degree also, it is known as the flip angle. Next one, another resonance result is there the magnetic movement of hydrogen nuclei move into phase with each other. Here in the picture we can see the out of phase and the in phase. Above we can see the out of phase. Out of phase means the hydrogen atoms receives not similar, means either it will receive more energy or it will receive less of energy. So, it will be not in but same speed and it is not in the same direction when we are giving to the external energy force. In the down image we can see in phase coherent or as coherence, that means the energy we are giving to the hydrogen atoms, the same energy next will be almost similar energy the hydrogen atom will be spinning around its own axis. So, whatever in phase atoms are there, those all are in same direction with same speed and at the same place it will be moving. Okay. Coming to a next one, that is final part, that is the MR signal, how the MR signal will be produced. Now, the MR signal is produced when the in phase magnetization cuts across the coil. So, how it will happen? Till now we have saw the precessional motion in the atom, then the resonance. So, what and how magnetism will be produced, that is also we saw. So, whenever the moving structure or magnetism will be there, over there if we are putting a conducting loop or the wire or the coil, so magnetization the voltage will be induced inside the coil. This voltage constitutes an MR signal. You can see in the picture again. Then next net magnetization vectors are there and the conducting loop coil will be there. So, magnetization will be occurring over there and conducting loop or the coil we have placed. That conducting loop or the coil will be having the voltage or constitutes the voltage which consists of an MR signal. Now, coming till now we have saw the how the MR signal we are getting. So, after giving current or after giving excitation pulse we are getting the MR signals and all, correct. So, what will happen after switching of that RF pulse, after switching of that excitation? So, free induction decay will be produced, free induction signal will be produced. When the RF pulse is switched off, the net magnetization vector is again influenced by the B naught, that is static magnetic field, and it tries to realign with it. The hydrogen nuclei must lose the energy given by them RF pulse, and process by which hydrogen loses the energy is called as a relaxation, means whatever energy we are giving to the hydrogen nuclei to go from the net magnetization vector towards in the transverse plane. Okay. So, after switching of the RF pulse, it will come back again into the net magnetization vector, that is known as the relaxation. So, the amount of magnetization in the longitudinal plane gradually increases, is known as the also recovery, and the amount of magnetization in the transverse plane gradually decreases, is known as the decay. I repeat, recovery means the amount of magnetization in the longitudinal plane gradually increases and the amount of magnetization in the transverse plane gradually decreases, is called the decay. Next one is the relaxation. So, relaxation during the hydrogen nuclei giving up the absorbed RF energy and the net magnetization vectors returns to the static magnetic field, that is B naught. So, it results in the recovery of magnetization in the longitudinal plane and decay in the transverse plane, as we have told already. So, the recovery of longitudinal magnetization is caused by the process termed as T1 recovery. So, the decay of the transverse magnetization is caused by the process termed as the T2 decay. So, coming towards the T1 recovery. So, T1 recovery is caused by the nuclei giving up their energy to the surrounding nuclei, or as lattice, and is termed as the spin lattice relaxation. So, we can see in the graph also the rate of recovery in an exponential process with the recovery time constant called as T1 relaxation time. In the graph we can see the 61% time it takes the longitudinal magnetization to recover in a tissue. I repeat, 63% of the longitudinal magnetization to recover in the tissues. T2 decay means it is caused by the magnetic field of neighboring nuclei interacting with each other, and it is termed as the spin relaxation. So, here what will happen, the rate of decay is also exponential process with a decay time constant called as T2 relaxation time. In the graph we can see it is the time it takes the 63% of the transverse magnetization to be lost, or as 37% remains in the transverse magnetization. So, next one is the pulse timing parameters. The repetition time is the time from the application of one RF pulse to the application of the next RF pulse for each slice, and is measured in the milliseconds. We can see in the graph the application of the one RF pulse. We can see the RF pulse is there once we started, and till the starting of the next RF pulse. In the middle of the slide, in the middle of the graph we can see application of one RF pulse to the application of the next RF pulse till that time, and we are measuring as a time also in the milliseconds. Till that time is known as the TR, that is the repetition time. So, TR does determines the amount of T1 relaxation that has occurred when the signal is read. Next one, coming to the echo time. It is the time from the application of the RF pulse to the peak of the signal induced in the coil, and is also measured in the milliseconds. So, once we are starting in the graph we can see once we are giving the RF pulse to the peak of the signal is there, to the peak of the signal has been induced in the coil. So, and also it will be measured in the milliseconds. So, that is this particular time is known as the echo time. Okay, and T thus controls the amount of T2 relaxation that has occurred when the signal is read. In summary, we can see about the atomic structure. There are different types of motions in an atom, that is electrons orbiting on its own axis, electron rotating around the nucleus, and the nucleus itself existing around, rotating around or orbiting around its own axis. Next one is the precession. Precession means the external force we are giving, or the external energy we are giving to the particular atom or the hydrogen atom to spin or the wobble. And in the precession we saw the precessional path, which is the path in the same direction the atom is rotating, and the precessional frequency and the speed at which the hydrogen nucleus spinning around its own axis. Okay. Then coming towards the resonance, and the resonance we can see that there are two results of the resonance. First one will be the flip angle, and the second one will be the in phase and the out of phase. In phase means the same direction with the same speed. Out of phase means the different direction and the different speed atoms will be having, and a different place it will be situated, all the atoms. So, next one is the MR signal. MR signal, whenever the magnetization will be there or the charged particles moves, magnetization will be occurs, and when at that particular place if we are putting the coil or the conducting loop, signal will be induced or the voltage will be induced inside the coil. So, that voltage constitutes around the MR signals. Yeah, that's all about my topic. These are all my references. Thank you.